The hypothesis that apple peels serve as potent contributors to metabolic and cardiovascular health is increasingly supported by a robust body of phytochemical research and preclinical evidence. While apples have long been celebrated as symbols of health and wellness, much of their protective power resides not in the juicy white interior, but in the colorful outer skin. The apple peel is not simply a barrier. It is a dynamic, metabolically active tissue rich in bioactive compounds that modulate inflammation, lipid metabolism, and glycemic control. Its dense concentration of flavonoids, particularly quercetin, cyanidin glycosides, and floridin, as well as its contribution to dietary fiber intake, make it a strategic component in the prevention of chronic metabolic diseases. Analytical studies show that flavonoid distribution in apples is highly uneven, with the peel containing up to 90% of the total antioxidant activity found in the whole fruit. Quercetin, one of the most researched flavonoids for cardiovascular and anti-inflammatory benefits, is primarily localized in the skin and is nearly absent in the flesh. Cyanidin 3 galactoside, an anthocyanin responsible for the red pigmentation in many apple varieties, is also concentrated exclusively in the peel. These compounds have demonstrated the ability to scavenge free radicals, inhibit oxidative damage to LDL cholesterol, and reduce the expression of inflammatory cytokines, which are key drivers of vascular aging and atherogenesis. Fiber content, though present throughout the fruit, is significantly boosted when the peel is consumed. Approximately 2.4 grams of dietary fiber per 100 grams can be attributed to the peel, including both soluble and insoluble forms. This blend promotes satiety, slows glucose absorption, and supports microbial fermentation in the gut, leading to the production of short-chain fatty acids, SCFAs, such as butyrate, molecules increasingly associated with improved insulin sensitivity and reduced inflammation. Animal and clinical studies underscore the bioactivity of these peel-specific components. Quercetin extracted from apple peel has been shown to lower systolic blood pressure and improve endothelial function in hypertensive models. In studies of high-fat diet-induced obesity in mice, supplementation with apple peel extract significantly reduced weight gain, serum triglycerides, and markers of insulin resistance. Human observational data also suggest a correlation between whole apple consumption, including the peel, and reduced risk of type 2 diabetes, potentially driven by the combined effect of polyphenol and fiber on glycemic modulation. In vitro assays confirm that apple peel extract more effectively inhibits LDL oxidation than flesh extract, a critical finding since oxidized LDL plays a central role in the initiation and progression of atherosclerosis. Furthermore, peel-rich extracts have shown the ability to blunt postprandial glucose spikes more effectively than pulp-only extracts, suggesting a favorable impact on glycemic variability, a key factor in the development of metabolic syndrome and diabetes-related complications. Given these insights, apple peels are now being explored for practical use in food science and therapeutic nutrition. Supplement formulations containing concentrated apple peel powder or extract are being marketed for heart health, glycemic balance, and weight management. These supplements aim to deliver standardized doses of quercetin, chlorogenic acid, and other polyphenol found in the skin, allowing for higher and more predictable intake levels than diet alone. Functional foods enriched with peel, such as fiber bars, smoothie powders, or bakery mixes, are also emerging as creative avenues to incorporate these bioactives into everyday diets without requiring changes in eating habits. Moreover, apple processing industries generate vast quantities of peel waste during juice and sauce manufacturing. Valorizing this byproduct into nutraceuticals or functional ingredients not only supports environmental sustainability, but also adds economic value to the agricultural supply chain. By converting peels into high-value polyphenol concentrates or fermented prebiotic powders, we can transform a discarded material into a therapeutic tool. In conclusion, apple peels represent one of the most nutrient-dense portions of the fruit, harboring flavonoids and fibers that exert multifaceted benefits on cardiovascular and metabolic health. Their ability to reduce LDL oxidation, lower blood pressure, stabilize blood glucose, and enhance gut microbiome activity positions them as a promising candidate for both dietary interventions and therapeutic applications. Future research may expand their role in personalized nutrition plans, particularly for individuals at risk for obesity, hypertension, or type 2 diabetes. The evidence strongly supports a renewed nutritional appreciation for this once overlooked outer layer.